For question number 1, you have to determine the smallest and second smallest possible bootstrap sample means based on the original sample that's given. Those are worth 1 point each, and for part B especially, I think it's a good idea to show work, just in case you have a minor mistake. Because if you make a minor mistake somewhere with part B and there's no supporting work, it's impossible to figure out how you ended up with that answer, and that turns it into a problem that's all or nothing with no partial credit. So just to be safe, I think it's a good idea to show work there, even though essentially it's just explicitly writing out algebra. For part A, I think there you can get away without showing work, because if you know how to get the smallest possible bootstrap sample mean, the algebra that you have to do is really trivial. So there, I think you can get away with it. But for part B, just to be safe, I think I would include the work. Question number 2, parts A and B are worth 1.5 points each. Parts C and D are worth 1 point each. For part A, writing out the parameter, if that's worth 1.5 points, then it's half of a point for the type and number, half of a point for the population, and half of a point for the specification. In part B, where you have to create a bootstrap distribution and then copy screenshots into your assignment, later in this video I'll go over how to copy screenshots into your assignment, but for right now I just want to focus on how the points break down. So if that's worth 1.5 points, then it's half of a point for picking the correct option in stat key, which really means constructing the correct type of a bootstrap confidence interval. So single mean, single proportion, difference in means, or difference in proportions. A half a point would be for having the correct original sample box, which would include the data entry, so essentially doing the data entry correctly. And then half of a point for having a dot plot based on that original sample with the correct number of bootstrap samples, so the at least 5,000. If you have less than 5,000 bootstrap samples, then you would lose that half point, so just make sure you click on generate 1,000 bootstrap samples 5 times. Part C, constructing the confidence interval using the formula where you compute the margin of error as 2 times the standard error rather than using percentiles. The main thing here is to make sure you're substituting in the correct numbers. The statistics should come from the original sample, underneath the original sample heading in the upper right corner on stat key. You should not be taking it from something in the upper right of the box that contains the dot plot, because that's going to be the mean of the bootstrap distribution that may or may not exactly match your original statistic, and if it doesn't, it's wrong. So the point estimate, your statistic, needs to come from the original sample. The estimate for the standard error that you use does come from the upper right corner inside that box of the bootstrap distribution. It's listed as standard error. That is where you get that. So just make sure you're subbing in the correct numbers there. That's the main thing. The algebra is pretty simple if you've got the right numbers. Part D, the correct percentiles for a 98% confidence interval. If that's worth 1 point, each blank is worth half of a point. But realistically, they're either going to be both right or both wrong. It seems like it would be very difficult to get one of those right and the other one wrong. The one thing I'll say here is just make sure that when you're thinking about this, that if you're going to use percentiles, the confidence level is the percentage that has to be in the center. So make sure you think of that 98% as being centered. And then if that's what's in the center, you can figure out what has to be left over in each of the 2 tails, which would have to be the same size. And then the 2 cutoffs for that central region would be where you would get your endpoints. From there, I think you can get the right percentiles. And just remember that the percentiles are named by the percentage of data below that point, which graphically would be to the left. Part A of number 3 is worth 1.5 points. The point distribution is identical to 2B, where it's half a point for the correct stat key option, half a point for the original sample box / data entry being correct, and then half a point for having a dot plot with the correct number of bootstrap samples that's based off of that original sample. The one thing that I want to mention here is when you're entering the data, you've got 6 measurements in the sample from supplier A, and you've got 7 measurements in the sample from supplier B. That extra cell at the end of the supplier A row is just there so that that table can accommodate the slightly bigger supplier B sample. So that last cell in the supplier A row is nothing. It's not a 0. You just ignore it. There are just 6 numbers at this point in the supplier A sample. Part B for number 3 is a lot like Part C for number 2. Just make sure you're substituting in the correct values. So the statistic needs to come from the original sample that may or may not match the mean of the bootstrap distribution. And then the standard error, the estimate for the standard error really, the standard deviation of the bootstrap distribution. That does come from there. So it'll be in the upper right corner of the box containing the dot plot. Part C, if that's worth 1 point, then it's 1 point for the yes or no and 1 point for the why or why not. To answer part C, make sure you use the interval. Then D, where you have to add in an extra measurement for supplier A. So once you add in that extra measurement of 10, both sample sizes should be 7. Once you enter the data into StatKey, you should have a mean for the supplier A sample of 69.857. You should have a mean for the supplier B sample of 77.429. And the difference in sample means, which will be listed as x1 bar minus x2 bar in StatKey, should be negative 7.57. That's how you know you've got the data entry correct. Then you can answer that question. You can fill in those blanks using the terms that are in the box underneath. There are 3 blanks. If it's worth 1.5 points total, then it's half a point for each blank. Question number 4. There's a CSV file that goes along with this. Having to retype that data by hand seemed like it would take a long time, so it would be easier if you could just import the data. That is part of the point of this problem, is being able to import data into StatKey. A little bit later in this video, we'll go through how to do that. You'll have to save that CSV file on your hard drive in order to get this to work correctly, but once you do that, then this shouldn't be too bad. Make sure you're using the correct variable, since for the bears there are 2 variables. There's the neck distance and then there's weight. So weights is in bold because that's the variable that you want. This is worth 2.5 points instead of 1.5. A couple of things are beefed up a little bit. It's half a point for the correct option on StatKey, the correct type of bootstrap confidence interval. It's 1 point for the original sample box / data entry this time because there's more to do. And if you're going to recopy them by hand, which I would not suggest, but if you really want to do it that way, there are 54 numbers that you have to retype, and you should have a sample mean of 182.889. And then it's 1 point for the dot plot, which breaks down into 2 half-point pieces. It would be half of a point for having the dot plot with 5,000 bootstrap samples. The other half point is for setting up the percentiles correctly. Part B is worth half of a point because there's only one thing you have to do. You just have to explain why not. That's fairly similar to 3C, just the second part of 3C. Conceptually, it's the same as that. This slide is supposed to illustrate how to upload data into StatKey. The screenshot that's in the upper left is a CSV file, which looks a whole lot like an Excel spreadsheet just without any formatting in it. The option that you want in StatKey is Upload File, so that's why that button is a different color in the screenshot in the upper right. Then in the lower left, you have to pick out your file, and then in the lower right, you have to pick out the variable that you want. If you look in the upper left, I've got 2 variables there, stipend and acceptance rate. If I wanted to estimate the average stipend, then I have to pick stipend, and when you select it, it gets highlighted blue. So this is what it would look like in action rather than just as screenshots. If I'm trying to estimate the average stipend, then I want a confidence interval for a single mean. Then I'm going to upload the data from the CSV file. So if I go to Upload File, then there's Physics Graduate School. I put it in a folder by itself. And then I have 2 variables there, which you can see it here. I can bring it back up. There's the actual CSV file. So we've got the schools, but there are 2 variables, stipend and acceptance rate. I said I wanted stipend. So back here in StatKey, if you click on the heading where it says stipend, that'll highlight everything. If you wanted acceptance rate instead, you would click on where right now it just says acceptance, since that heading is too long. If I click on OK, then that data is stored in there, and then you can do what you would normally do. Generate the 5,000 samples, and then you can get your confidence interval either using the original sample mean and then the standard deviation of the bootstrap distribution that's right there, or using percentiles with the 2-tail, just like we've done before. The last slide is in here to illustrate how to copy a screenshot into a Word document. Going through the screenshots that are here, the first one is just StatKey. The second one in the upper right is that screenshot in Paint. In the bottom row, I have an open Word document, and then those pieces in there, the dot plot, and then the original sample box. The function that you need to be sort of comfortable with, I guess, is print screen. which will just take a screenshot of everything on your screen. I'll show you how this works. This was the last thing I had in StatKey. So let's say I want to get a screenshot of this. If I click on print screen, then if I open Paint, there it is. And now I can just crop out the parts that I want. So the two things I want are the original sample box and the Bootstrap dot plot. So there's the original sample box, and I'm going to copy that and then paste it into the Word document. So there's that. It doesn't have to be quite that big. I guess if you want to resize it a little bit, you can. Then I also need the dot plot. So if I go back here, and I'll crop out this dot plot, copy, and paste, and there's that in the Word document as well. You can do it that way. That's conventionally the way that I would do it, but I'm used to those older commands of print screen and that kind of stuff. What you can also do, and I guess I need to leave myself a little bit of room here for this, is you could print screen this and then copy that directly into Word. You'll get the entire thing. I'm okay with you doing that, but if you're going to do this, make sure you don't save your file as a PDF. Because if you save your file as a PDF, you can't resize anything. Just leave it so that it can be resized. If you save it as a PDF, you can't resize the picture. But if you saved as a Word document, if I click on this thing, if I think, well, I don't know if I can really read that mean with it being that small, I can just make it bigger. And you can't do that if it's a PDF. So if you're going to save the file as a PDF, I would say crop out individually the parts that you need, like this up here. But if you're going to save it as a Word document, I guess you can do it either way, whichever you prefer.